Right, so today we're going to be integrating y squared times by 1 minus y squared rooted. So firstly we're going to use substitution, a type of trigonometric substitution. So we're going to say y equals sine theta. So we can say that now we need to get everything that's in what we're integrating. So y squared equals sine squared theta. 1 minus y squared equals cos squared theta, because sine squared theta plus cos squared theta equals 1, so it goes up to there. And then we can say that dy by d theta equals cos theta, so dy equals cos theta times d theta. So if we're going to take this and substitute it in, this becomes y squared sine squared theta times by 1 minus y squared is cos squared theta, power of a half times by dy, which is cos theta d theta. And now we can say that this is cos squared theta rooted is cos theta times cos theta, which is cos squared theta. And now we can say that this is, if we use the power reduction formula, we can say that this is a half of 1 minus cos 2 theta times by a half of 1 plus cos 2 theta times d theta. So this equals a half times a half is a quarter of the integral between 1 and minus 1 of 1 minus cos 2 theta 1 plus cos 2 theta, all times by d theta. So this gives you a quarter of 1 minus cos 2 theta plus cos 2 theta 0 minus cos squared 2 theta times d theta. So again, we're going to need to use the power reduction formula to get rid of the squared. So we're going to say that it's a quarter integral of 1 minus and then a half of 1 plus cos 4 theta now times by d theta. So you can take out the half again, so we get 1/8 of 1 minus 1 plus cos 4 theta times by d theta. So we can split this up, so we can say this is an 1/8 of 1 times d theta minus an 1/8 of 1 minus 1 0 cos 4, so we just left with the cos 4 theta. So integrate this, we get 1/8 of theta between 1 and minus 1 minus 1/8 of this between 1 and minus 1. What is cos 4 theta integrated? Cos theta goes to sine theta, and then you divide by the differential of the bracket. So it's sine 4 theta over 4. So the last thing we need to do is these boundaries are in terms of y. Now we need them in terms of theta. So if y equals 1 and y equals sine theta, 1 equals sine theta, so theta equals inverse sine of 1, which is pi over 2. And then for y equals minus 1, we do the same thing. We'll get theta equals minus pi over 2. So if we bang that in at the top, we're integrating this, which is theta between pi over 2 and minus pi over 2 minus this. Between pi over 2. So first we can look at this, because I've noticed that sine of 4 times pi over 2 is the same as sine times, this is going to cancel and be 2, because 4 over 2 is 2 pi, which is sine 360 in degrees. This is in radians, which is 0. So this whole term is going to go to 0, because for the negative it will go to negative 2 pi, so that would be 0 as well. So all we need to do is think about this one. So we were thinking about 1/8 of pi over 2 minus pi over 2, which equals 1/8 of pi over 2 minus pi over 2 is pi. So we get pi over 8 as our final answer.